So good morning, good afternoon, and good evening, everyone, based on the time zones you all are coming from. My name is 𝐑𝐨𝐥𝐞-𝐁𝐚, and I have been into this IT domain for around 15 years now. So as a part of today's session, we will be talking about what exactly is MLOps, why we need it, how exactly the ML operations work, and then the advantages and the hands-on on top of it. So that is what we will be talking about. Now, in terms of the ML operations, so what exactly MLOps is? So MLOps is basically a given set of practice that drives a seamless integration between our development cycle and our overall operations, which can also transform how exactly the organization is going to handle a given set of data. So that is going to be managed by using the MLOps altogether. So it allows us to make sure we are able to eliminate the wastage. We are able to automate the entire solution without having much of the physical challenges and then get a good insight from there. So in terms of the machine learning operations, we can go ahead and make use of the complete life cycle for MLOps, which includes three broad phases of designing the ML powered application, the experimentation, development, and the ML operations available there. So these are the core components of ML operations. And just like we have DevOps, same way we have ML ops as well as a part of the engineering domain. So it's like a core function of machine learning, which is focused on streamlining and processing of taking the machine learning models to production and then maintaining and monitoring them. So MLOps is like a collaborative function, often comprising data scientists, DevOps engineers, and the IT team. So it is a useful approach for creation and quality of machine learning and the AI solutions that we have by default. So by adopting the ML operations approach, data scientists and machine learning engineers can collaborate and increase the pace of model development and production. So taking this forward, in terms of design, we have the requirement engineering, the use case prioritization, the data availability check, and then we have the model development for the same. And then in terms of the testing and validation, we have that comes under the model development. And then we have operations where we have model deployment, the CI/CD pipelines, and monitoring and triggering. So all these three phases, they are all connected to each other, and they are going to have a big impact on why or how exactly it is going to be structured. So let's discuss on why exactly ML operations work. So in terms of the ML-based operations, why exactly it is required? So there are multiple advantages of using the ML operations. So the main principle is, we can say productionizing the machine learning is pretty difficult. The machine learning life cycle consists of many complex components like data ingestion, data preparation, model training, model tuning, model deployment, model monitoring. We have to explain the code and much more. So it also requires the collaboration and hands-off across teams, from data engineering to data science to ML engineering. And naturally, it requires the stringent, or you can say the stringent operational rigor to keep all these processes synchronous and working in tandem. So MLOps encompasses the experimentation, iteration, and continuous improvement of the machine learning lifecycle. So there are multiple benefits of using the ML operations as well. So the primary benefit of ML operations are efficiency, scalability, risk reduction, and in terms of the principle of MLOps, we have the automation, which allows us to automate the workflow steps without any manual intervention. For example, we want to scrap some content from the web, so we can do that easily. Then we have the continuity, which includes continuous integration, deployment, testing, and monitoring. And then we have versioning, which tracks the ML models and data sets with versions control systems. And then we have the experiment training, where we have multiple experiments on the model, which are parallelly executed. Then we have testing, which tests for features and data. Then we have monitoring to ensure that the ML model performs exactly as expected. And then we have the reproducibility, where we should produce identical results given the same input as a fine. So now how exactly the ML operation works? So we have different phases available here, starting from data extraction, data analysis, data preparation, and then we have model training, model evaluation, validation, and then serving and monitoring. So the main benefit, first of all, of using the ML operations, so basically it allows us to have vast scalability and management, or can say when it comes to thousands of models which can be overseen, controlled, managed, and monitored for continuous integration, delivery, and continuous deployment. Now, specifically, MLOps provide reproducibility of ML pipelines, which enables us to have a tightly coupled collaboration between different data teams, thus reducing the conflict with DevOps and IT. And risk reduction in terms of the machine learning models often need regulatory scrutiny and drift check, and ML operation enables greater transparency and faster response to such requests and ensure greater compliance with an organization or industry's policies. Now, the span of MLOps in machine learning projects can be as focused or expansive as the project demands. In certain cases, ML operations can encompass everything from the data pipeline to model production, while other projects may require ML operations implementation of only the model deployment process. A majority of enterprises deploy MLOps principles across the EDA, data preparation, and feature engineering, model training and timing. Then in terms of model review and governance, model interference and serving, model monitoring, and automated model retraining as well, or you can say retraining. So in terms of the ML operations workflow, so first of all, it starts with the development team, which simply pushes the code in the Git repository. And then in terms of the data ingestion, once the code has been pushed, so here it goes into the CI as a part of the ML pipeline, which gets transferred, which gets saved into the container registry component. So in this pipeline, we have the data transformation, which is going to be done. And then the config updater is going to update the image in the staging configuration. And then it is going to be sent as to a service where we can make use of the Kubernetes deployment as required. So as a part of structured learning program here, so first of all, we discuss on the overview of DevOps, and then we talk about the version control with Git. Then we talk about the Git, Jenkins, and Maven integration. Then we talk about the continuous integration using Jenkins, configuration management using Ansible, the monitoring using Prometheus and Grafana, and then containerization using Docker, and then the orchestration using Kubernetes, and then at the end, the AWS EC2 and IAM based configuration setup here. Now, if we talk about the advantages of MLOps, then we do have the reproducibility of the code, easy deployment, higher precision, and an effective management of the code that we have here. So as we discussed, there are multiple, we can say, advantages offered here in terms of it getting the code and that in a higher speed, making the entire code much more maintainable than the others. And using that, we can ensure that we are going to get an effective management of the code and structured pipeline that we will be getting as a part of the setup. And unlike DevOps, MLOps is much more experimental in nature. So data scientists and the ML engineers, they have to tweak various features like hyperparameters, parameters, models, while also keeping track of and managing the data and the code base for reproducible results. Now, besides all the efforts and tools, the ML industry is still struggling with the reproducibility of experiments. Now, then we have the hybrid team composition. So the team needed to build and deploy models in production won't be composed of software engineers only. In an ML project, the team usually includes data scientists or ML researchers who focuses on exploratory data analysis, model development, and experimentation. And they might not be experienced software engineers who can build production class services. And then we have testing. So testing on ML system involves model validation, model training, and so on. In addition to the conventional code test, like we have the unit testing and integration testing available. Then if you talk about the automation deployment, so we can't just deploy an offline trained ML model as a prediction service. We'll need a multi-step pipeline to automatically retrain and deploy a model. So the pipeline adds complexity because we need to automate the steps that the data scientists do manually before deployment to train and validate new models. And production performance degradation of the system, mainly due to the evolving data profiles or simply training server skew. So ML models in production can have reduced performance, not only due to the suboptimal coding, but also due to constantly evolving data profiles. So models, they can decay in more ways than conventional software systems, and that's why we need to have a setup of MLOps defined. So MLOps serves as the map to guide individuals, small teams, and even businesses to achieve their goals, no matter their constraints, be it sensitive data, fewer resources, small budgets, and so on. So we decide how big we want our map to be, because the MLOps are practices that are not written as in stone. So we can experiment with different settings and only keep what is working for us. So even in terms of the major phases of MLOps, we can list it down. So the first phase is for framing the ML problems from the business objectives. Then we have the process of architecting the ML and data solutions for the given problem statement. And then the data preparation and processing, which is part of data engineering itself. And then we have the model training and experimentation. And then we simply go ahead and combine this with other problem statements, including the building and automation of the ML pipelines. And then at last, deploying the models to the production, we can say team, or we can say a given system. And then at last, monitor, optimize, and maintain the model. So first of all, if we talk about the process of framing the event problems, so machine learning systems development typically starts with a business goal or objective. So it can be simple goal of reducing the percentage of fraudulent transactions below 0.5%, or it can be building a system to detect skin cancer in images labeled by dermatologists. And these objectives often have certain performance measures, technical requirements, budget for the project, and KPIs that drive the process of monitoring the deployed models. Then we have architecting the ML and data solutions for the given problem statement. So after the objective are clearly translated into ML problems, the next step is to start searching for appropriate input data and the kind of models that are to be tried for that kind of data. So searching for data is one of the most strenuous tasks. It's a process with several tasks where we need to look for any available relevant data set, check the credibility of data and its source. So these objectives, they often have certain performance measures, technical requirements, budget of the project, and KPIs that drive the process of monitoring the deployed models. Then we have data preparation and processing. So data preparation includes tasks like feature engineering, cleaning, formatting, checking for outliers, imputations, and then selecting the set of features that contribute to the output of the underlying problems. So a complete pipeline is to be designed and then coded to produce clean and compatible data to be fed to the next phase of model development. An important part of deploying such pipelines is to choose the right combination of cloud services and architecture that is performant and cost effective. For example, if we have a lot of data movement and huge amounts of data to store, we can look to build data lakes using AWS S3 and AWS Glue. And we might want to practice building a few different kinds of pipelines, like we have batch versus streaming, and try to deploy those pipelines on the cloud. Then in terms of the fourth model, we have model training. So as soon as our data is prepared, we move on to the next step of training ML model. So now the initial phase of training it is iterative with a bunch of different type of models. We will be narrowing down to the best solution using several quantitative measures like accuracy, precision, recall, etc. And we can also use qualitative analysis of the model, which accounts for the mathematics that drives the model, or simply put the explainability of the model available. And then we have the building and automation of the ML pipelines. So ML pipelines are to be built keeping in mind the following task, which is basically identifying the system requirements, choosing an appropriate cloud architecture, constructing the training and testing pipelines, tracking and auditing the pipeline runs, and then performing data validation. And then we have deploying models to the production system. So we do get the static deployment or embedded model, in which is the model where it is packaged into the installable application software and then deployed. And then we have dynamic deployment, where the model is deployed using a web framework like Fast API or Flask, and is offered as an API endpoint that responds to user request. And then we have monitor, optimize, and then maintain the models. So an organization needs to keep an eye on the performance of the models in production, but ensure good and fair governance. So governance here means placing in control measures to ensure that the models deliver on their responsibilities to all the stakeholders, employees, and users that are affected by them. So as a part of this phase, we need data scientists and DevOps engineers to maintain the whole system in production by performing multiple tasks like keeping track of performance degradation and business quality of model predictions, setting up logging strategies and establishing continuous evaluation metrics, troubleshooting system failures and introduction of biases, and then tuning the model performance in both training and serving pipelines deployed in production. So these are different phases of ML operations. All right then. A big thank you to you all for being a part of today's session, and have a great day ahead. Take care. Bye-bye.